Let's discuss indirect variation first by relating it to direct variation. In direct variation, if we talk about the constant of variation, a letter that we call k, that is usually in the equation y equals k times x. So the constant of variation is being multiplied by the variable x. For indirect variation, this equation is much different. In indirect variation, x times y equals the constant of variation, k. An equation that relates ordered pairs, and we're talking about x1, y1, x2, y2, these would be ordered pairs. The equation for direct variation is y1 over x1 equals y2 over x2. For indirect variation, if we have two sets of points, this equation again is different. It's x1 times y1 equals x2 times y2. Let's compare also the graphs of direct versus indirect variation. So let's make the constant k be 6. So the constant of variation is going to be 6. For indirect variation, that means we want to graph the equation y equals 6x. This is a relatively easy equation to graph because the y-intercept is 0. So I can put a dot at 0. And my slope is 6. So 1, 2, 3, 4, 5, 6 over 1. Or up 6 again over 1. Or down 6 and back over 1. So really these are the only 3 points I can fit. Ugh, terrible line I drew there. These are the only 3 lines that I can fit on this graph. But the main point is that direct variation graphs as a line. Indirect variation, however, let's take a look at that. If the constant is k, I want to graph all of the ordered pairs where x times y equals 6. And we haven't talked about how to graph these equations yet. So let's use the one method that we know how to with graphing and just find a bunch of ordered pairs. So I'm going to make a t-table of x's and y's. If x is 0, then it's 0 times what is 6? Well, there isn't anything. So this is kind of strange, but I cannot input 0. But let's continue on, and I'll input 1. Well, 1 times what is 6? 6. If x is 2, 2 times 3 is 6. If x is 3, 3 times 2 is 6. So I have all of these numbers that multiply to be 6. Let's graph those. I have 1, 6, 2, 3, 3, 2. Let's choose one more number on this side. I know that if x is 6, y is 1, so this is also on my graph. There's kind of a symmetry going on here where if I have 1, 6, I also have 6, 1. So it seems that this is the graph here. And now if you notice, as I get towards 0 here, if I plug in 0, there isn't a value, but the graph comes up and hugs this way. These aren't all of the points on this. Let's look at some of these negative points. So if x is negative 1, y could be negative 6. And if x is negative 2, y could be negative 3. And if x is negative 3, y could be negative 2. I'm just finding 2 pairs of numbers that multiply to be 6. This equation is pretty easy to find a bunch of ordered pairs for. So I pretty much have the same set as I do over here, just with negative numbers. So, negative 1, negative 6. Negative 2, negative 3. Negative 3, negative 2. I graphed this one on the wrong spot. Negative 6, negative 1. There's a symmetrical looking graph in the third quadrant for this indirect variation as well. Indirect variation has a very strange looking graph But the nice part about it, it's very easy to find ordered pairs that fit along with it. Indirect variation is a relationship between two variables, where as one increases, the other decreases proportionally. And we can kind of see that in the graphs that we just drew of indirect variation. That as x increases, that is, as we get larger and larger x values here, the y values are smaller. An example of indirect variation in the real world has to do with the number of days it takes to build a house will vary indirectly to the number of people working on the house. So that if you need the house to be built in less days, this needs to go up. Or if you want more days, if this is increasing, that it's now 10 days or 20 days, as this increases, that means less people are working on the house. As one goes up, the other goes down. Let's graph another example of indirect variation. If you were given this equation, I would rewrite it so that x and y are on the same side. So to do that, I'm actually just going to cross multiply. X times y equals negative 4. And now I'm certain that this is indirect variation because this is written in the general form and k is negative 4. The easiest way that we have to figure out the graph of indirect variation is just to list a bunch of points. And lucky for us, it's easy to plug in points. I'm going to start with 1. If x is 1, y would have to be negative 4, because these need to multiply together to be negative 4. If x is 2, y would have to be negative 2. If x is 4, y would have to be negative 1. I'm also going to plug in a few negative values for x as well. And these pairs, since these are the nice number that multiply to be 4, will help me find the other ones. I can just switch the negative to the other number. So all of these are ordered pairs that work in this equation. Here are the points that we just found using a t-table. Now, if we're not sure what this graph is supposed to look like, some more points might be helpful. I'm going to try to see what happens if I plug in bigger numbers for x. Okay, so if x, let's say, is 6. 6 times what is negative 4? Well, it would have to be some kind of fraction, and I believe it would be the fraction 2/3. Yep. So 6 and negative 2/3, 1, 2, negative 2/3 would be right here. So it seems to me that this graph is going to keep coming up and hugging the x-axis right here. As my x gets larger, my y is going to become really, really small. But the same thing happens down this way. My graph is going to go into this direction. The mirror image of that is happening in the opposite quadrant. This and this. This graph does not touch either axis, the x-axis or the y-axis. To find missing values in a set of ordered pairs, we need to remember from the first slide the equation that relates indirect variation with ordered pairs. And that would be this. Oop, this is supposed to be a 1. So I can just plug in to this equation. x1 is 4, y1 is 54, x2 is 8, y2 I still don't know. I'm just going to keep it as y with a little sub 2 here. All right, 4 times 54 is 216. So 8 times what is 216? If I divide both by 8, I'm going to get 27. Oop, 27 on this side. So y2 must be 26. Three friends on a fishing trip pay $100 each to share the rent of a cottage. The cost per person varies indirectly as the number of people sharing the cottage. How many people should share the cottage to reduce the cost to 60? What I want to do here is create two sets of ordered pairs. I know that 3 relates to 100. So I'm going to let this be my first set of ordered pair. And I want to know what value, x, would relate to 60. If I think of this as my x1, y1, x2, y2, then I can use the formula for indirect variation that compares 2 points. So 3 times 100 will equal what times 60? 300 equals x times 60. If I divide by 60, I will find out that I need 5 people to share the cottage so that the cost would be 60. And this makes sense if you don't want to do it using the formula for variation. You know that the cottage costs $300. That's 3 friends each paying $100 each. Well, if the total cost is $300 and you want each person to pay 60, 300 divided by 60 is 5.